Today, we're going to be exploring a Python solution to a common coding problem, adding two numbers represented as linked lists. This is the second problem on LeetCode. We'll dive into the code and provide a thorough explanation of how it works. The problem we're solving today involves adding two numbers that are represented as linked lists. Each node in the linked list represents a single digit, and the digits are stored in reverse order. Now, before we get into the video, if you guys want to see more videos like this, drop a like down below. It helps us out tremendously with the YouTube algorithm, and with that out of the way, let's hop right into it. So we begin by defining a class called solution, which encapsulates the logic for adding two numbers represented as linked lists. Inside the class, we have the method called addTwoNumbers, which is already given, that takes in two linked lists, L1 and L2, and returns the resulting linked list. To handle the creation of the resulting linked list, we create a dummy head node and initialize a tail pointer to it. This dummy head will help us simplify the insertion process. We also declare an integer variable called carry to keep track of any carryover that may occur during addition. The core of the algorithm lies within the while loop. It continues until both linked lists are fully traversed and there is no remaining carryover. Within each iteration of the loop, we extract the digits from the current nodes of L1 and L2, respectively. If either list has been fully traversed, we assign a value of 0 to the corresponding digit. We then compute the sum of the two digits along with the carryover from the previous iteration. The resulting sum is divided by 10 to obtain the digit to be stored in the current node of the resulting linked list. We take the modulus 10 of the sum to get the digit value. The carryover of the next iteration is obtained by dividing the sum by 10. We create a new node with the computed digit and append it to the tail of the resulting linked list. The tail is then updated to the newly added node, maintaining the correct position for the next iteration. We move the next nodes in L1 and L2 if they exist, using a conditional ternary operator to handle cases where a list has been fully traversed. Once the loop ends, we have the final resulting linked list. We assign the next pointer of the dummy head to the result pointer. Before returning the result, we set the next pointer of the dummy head to none to prevent any lingering references and potential memory leaks. Right, let's go ahead and run this. And that's going to be it for this video. If you guys enjoyed or found it helpful, drop a like down below, leave a comment if you have any questions, and subscribe for more. We'll catch you in the next one.